I bought a 3D printer. Let's talk about that. So what is 3D printing? Well, unlike CNC routing or milling or processes like that, it's an additive process. What this means is that layers of material are built up one by one, much like printing thousands of sheets of paper and then gluing them all together in a big stack. It's the same sort of idea, except in most cases using some kind of plastic or metals. It has to be a material that can melt. And essentially you're drawing the shape over and over again. You're drawing the cross section of the shape on top of the previous layer so that you can build up a finished part. What are the benefits of 3D printing then? Well, because you're adding layers of plastic one on top of the other, you have much less waste plastic, or effectively none at all, depending on what the design is. This is much better than a wastage process like CNC routing or milling, where you're just kind of removing the excess material, which means you can just waste loads of metal or plastic by cutting it down, which is not the best thing, especially if you're on a budget. However, there can be some waste plastic in a printing process. If you're printing overhangs that need support, then obviously you will end up removing that support, so that is classed as waste. Theoretically though, most parts can be printed without any support, and thus it is a very near to 100% kind of material efficiency in terms of the amount of material that's being used when it's being printed. Also, because printers are three-dimensional machines, you can print some fairly complicated objects in 3 dimensions. For example, this little name badge I've just printed has my name on it, or my second name. So let's talk about the 3D printing process on the actual machine. We start off with the material. This is a spool of PLA plastic. The material pretty much always comes in this kind of thin wire of plastic known as filament. And this is essentially a long strand of the plastic that's going to be fed into the extruder. This particular filament uses 1.75mm diameter. You can get 3mm diameter, although the trend is towards 1.75 these days. Once the filament has come off the spool, it's being pulled off the spool by this stepper motor here. It runs down through this main kind of guide area where the stepper motor has a little gear that pulls it through, and then down into the hot end, which is down there. The hot end then melts the plastic with this little thermistor that you can just see here, heater, and it's extruded out the nozzle that you can just see at the bottom there, and is kind of deposited onto the bed, as you can see here, or onto the previous layer of plastic. So that's how the machine works. The rest of the mechanics and electronics are much the same as any other CNC machine. We use stepper motors to move either lead screws, or in this case threaded rod, or belts, precise distances so we can kind of draw out a part, as it were. So let's talk specifically about this machine. Stock, the machine came with all the stepper motors, all the smooth rod and the threaded rod for the Z-axis, all the belts, all the pulleys, and some things were even pre-built. The X-axis was pre-built, the Y-axis was pre-built, and you just needed to bring everything together. You needed to build the main chassis and attach all the parts together. There are some parts on here that are not stock. I'll explain about those later, but for now I'm just going to discuss what came stock with the machine. The actual chassis of the machine is made out of around about 5.5mm thick laser cut plywood, and then it's got this kind of like what is almost like paint but almost a bit more rubbery than that kind of finish applied to it. I'm not sure about the exact material. And then there are some printed parts as well, such as these parts here for the different axes. And then it also comes with some metal fittings, so more smooth rods down here, the nuts for the main kind of structural part down here, and also these metal attachments for the different bearings and things like that. Stock, the circuit board comes like this. This is the G-Tech GT2560 circuit board. It's essentially an Arduino Mega and a ramps board put together. And that means that obviously if one part of it breaks, you kind of need to replace the whole thing, but it does add some convenience, and it has been a very good board for me so far. Nothing's gone wrong. I've had no issues with adding fans and things like that, so I've been really happy with this so far. The main power supply for the system is this power supply here. It does 230 volts or 120, 110 volts, and basically the AC wiring comes in here, and then you get your 12 volts out here, and that's run across the top of the printer to the main circuit board. And finally, we have an LCD screen paired with an SD card reader. So this shows the status of your print and other information such as the temperature of the hot end and things like that. And then you can also print directly from the little SD card that's back there. Finally, the machine has a heated bed, which is really helpful for ABS prints. I haven't actually printed an ABS yet, although I do use the heat of the bed just to help the PLA stick a little bit. And it also comes with this glass and the clips. You might want to add something like build tack or something to this to improve the adhesion to the bed, as I have had problems with it not sticking. But this works perfectly well with a bit of just standard kind of Pritt glue stick, something like that. The machine comes with all the wiring you need to connect it all together, and it's very plug and play. So it's just got these little kind of plug-in sockets, which is really great. So there's no soldering involved in this. So if you don't have a soldering iron, don't worry about that. You can build this machine perfectly fine without the use of one. So, upgrades and changes. The first upgrade I actually made to this machine was I added this spool holder. It comes with a little triangular spool holder that's kind of just meant to sit to the side. I found that put way too much tension in the filament when it was kind of being fed down, which can cause issues with filament flow, the flow of plastic, and so you can get defects in the sides of your parts. So if you can, try and make yourself a spool holder out of PVC piping or something like that. I just used some bits of plywood and a kind of old handle from a broom and just screwed it all together. I cut it out on the scroll saw over there. And this just helps with the feed of the filament, make sure there's not too much tension. It also means the extruder motor can just rotate the spool as it pulls the filament through. The next big modification that I made was these fans. Stock, the extruder comes with no active cooling for the actual part, which means you're going to have issues with things like bridging. Fans really help with that, and they also just help with general print quality, as cooling the layers more quickly means that they're not going to bend and warp when the print head moves past on the next layer. You can get this really awful issue called curling, where basically the layer below is still molten, and so the print head actually pushes it out, and so you can lose definition and details in the models that you're trying to print with curling. So definitely get some active cooling on here. And finally, a big upgrade I made really was these parts here. Again, this is a custom design because I couldn't find anything online that was quite right. These are the kind of Z-top plates. The original plates, you can see here, you can see there are two holes. One hole for the Z-axis threaded rod and one for the smooth rod. And you would think kind of naturally that will be better, because then you've got support at the top for the Z-axis threaded rod. That is, however, not the case, as you'll find out online on the RepRap forums from people who have a lot more experience in this than me. The only time that's better is if you have a system that is perfectly straight from the connector all the way up to the top of the threaded rod. That means you can have no bow in your threaded rod whatsoever, which is rarely ever the case. It takes ages of calibration to get it just right, and there's no point really, because eventually it'll just go out of whack anyway and you'll have to recalibrate it, spend all that time. So the solution is to free the top of the threaded rod, and that means there's a certain amount of give in the oscillation of the rod, and that isn't translated into the x-axis here, which means that the print head doesn't move and you don't get this ridging effect on the side of your prints. So with that, I'm done talking about this machine for now. If you have any questions about it, please feel free to drop me a comment and I'll try to get back to you and answer as best I can. You'll be seeing a lot more of this in the future. I'm going to be using it in projects for casings and things like that, mechanical parts, and so you're going to be definitely seeing the kind of fruits of its labour, as it were, in other projects that I'm doing. And I also plan to do some time-lapse videos of it actually printing things. I've already done one, you'll have seen that on the channel, so I'll definitely upload those as and when I actually print things. But for now, thanks for watching. Please leave a comment, like and subscribe if you like this content, and I'll see you next time.